about what we have. We've got sections 5.1, 10.2, 3, 4, and 6. Now, 10.2, 3, and 4, that was your, these were your parabolas, up, left, and right. The 10.3 was the circle. 10.4 was the ellipse, when you had those going either direction. Now, we start breaking it down even further. There's two formulas here, one formula here, two formulas here, all built in to the shifts in 10.6, right? Now, if you start going through it, the formulas are all very similar, but it's not something that you really need to memorize. Because, take your calculator out. What I want you to do, you might have it on here. This is why I never really stress the fact of memorizing this. You ever notice that I never said you need to memorize this? Yeah. Did you ever notice that? Yeah. If you hit the button that says apps, some of you might have it, some of you might not.
Wait, I haven't gotten the app.
Apps is the purple button.
Got it.
Okay? You hit the button that says apps. If you scroll through there, you might see something that says conics. If you do, you're great. If you don't, it's not a big deal because I'm going to...
Get it?
He skipped it.
Oh, sorry, it's number 8.
Oh, I did not see it.
What if you only have like finance?
I will... When we need to get to the point of needing some of these apps on a regular basis, I'll make sure I install them on your calculator. Right now, you really don't need them. Well, here's what I'm going to do. I'm going to print these. Okay? What I'm going to do is I'm going to print these. If you go through these, you'll notice that you've got the circle equation. You've got the ellipse equation. And if you look here, guys, all three of the ones that we've been working with are given to you in terms of H's and K's. Do I need to bother to write them if they're centered at the origin? I don't, because what's your H and K if it's centered at the origin? 0 and 0. So what I'm going to do is, I know some calculators have this, some don't. One of the days later on, I don't know, maybe later this week, if we have a little bit of time, I'll make sure I install all of the programs that I want you to have for right now. Some of these calculators have them, some of them don't. I will have a sheet on there that mirrors this on the test. You'll get these. It'll tell you exactly like it would in your calculator. Nothing else changes. So if you have it in your calculator, great. If you don't have your calculator, well, you'll have this here. You'll also notice that they have, we didn't do this for them, so don't worry about that. They have pictures. It tells you which way it's being stretched. If the a squared is underneath the x squared for an ellipse, notice it's stretched left and right. And it's stretched vertically. So you can't screw that up. Okay? Yes, sir? You can graph them, but you still have to be able to label and give me all your parts and values and everything.
It gives me a circle.
I know. Okay? I know. It doesn't give you any of that other stuff, though. All right? Yes, yes.
Are you going to learn how to do a hyperbola?
We're going to start the hyperbola on Wednesday. Like I was saying, is that since we only have 3 days this week, if we had 4 days, we could have gotten the hyperbolas in. But what'll happen is we're going to start the hyperbola stuff on Wednesday, which is fine because it's going to take us a couple of days to get through the basics of the hyperbola because there's so many parts. In hyperbolas, you have centers, vertices, co-vertice, focus. You have a rectangular box to draw out. You have slant asymptotes to worry about. Slant asymptotes. But yeah, there's a lot of pretty cool stuff out there. But we have, guys, I want to be able to spend the time to really go in there and define it through because you use what are called these slant asymptotes a lot in pre-calc. When you get into the conic stuff in pre-calc, you're not only going to have parabolas that go sideways, you have them going on an angle.
No, I was right.
I told you that.
What? You said no.
Well, not in this class, I said next year. So you guys are going to have the hyperbola like this over the next day or so. There's a lot going on with these things, and you'll have them that'll go this way, and then next year you'll have them go that diagonally like that as well. So, what's that? It's not, it really isn't that difficult. You're going to be pleasantly surprised at how easy hyperbolas are to work with. There's just a lot going on.
Are
There's
there
a lot of things
ellipses
going on.
going that way too?
There will be, yeah, but that's all next year. For right now, it's just, I'm showing you guys that you will get to that stuff. Yes, sir?
Do parabolas go through the z coordinate ever?
In 3-dimension?
Yeah.
I don't believe we graph, we worry about 3-dimensional curvature. That's when you'll get to I think you do that in, yeah, I think you do that in 3-dimensional calc.
But then you do it.
That'll be like calc, I think that's calc 2, calc 3. Your brother's probably doing that now.
Calculus, I don't even think he's in calculus, he's in engineering.
Well, he's already taken it. I'm pretty sure he took that. I think it's DPQ.
Okay, I don't think he's in any calculus right now. Are you
Let's go through a couple of these things then. What's that?
Yeah, like how much
Now I'm sitting getting really
like,
depressed.
It depends upon what your major is going to wind up being. Is depending upon the type of math you have to have. I mean, if he's Cam, he's in engineering. He's got to have a boatload of math, a ton of physics and stuff, and it's all built into that. If you get into economics or financial stuff, you start doing the business stuff, accounting. There is what they call business calculus. You'll do that, but you'll also take a lot of stats class, and there's a lot of financial math stuff you do. But it's not like straight calculus stuff. Anyway, here's what I want to review with you guys real quick. A couple of the so there's no questions on otherwise in 5-1. The circle stuff.
No.
Pretty simple. Okay. Let me look at what we did here. Remember when we went back to 5-1? Yeah, this was that first section of the parabolas, and we talked about the 3 forms of. Wouldn't be a bad idea. So we talked a little bit about these 3 forms of parabolas when they were just up like a cup or down like a frown. We wrote out how you found your vertice. We wrote about how you can tell if it's a maximum or a minimum. Axis of symmetry. We got ordered pairs for separate symmetric twin points and things like that. This form was your standard stuff that you guys have been doing a long time. Opposite of B over 2A got you your vertex and so on. The other 2 forms were the ones that were newer. The other 2 forms were your vertex form and your intercept form. What I want to do here real quick is just kind of remind you guys of what you have to do or what these forms allow you to be able to do. Okay? If I'm looking at vertex form, let's say I had an equation that was y equals -2 times the quantity x minus 3 squared plus 6. And I was told to graph all the info that I needed to know out of that. Right then and there, that is in what you call vertex form. The h and k are there for it. That's your vertex for the parabola. So where's the vertex located on that? 3, 6. So my h and k is at 3, 6. Oops. So if I go to plot that, I know it starts there. My A value is negative, so what direction will this go? It goes downward. So when we worked with these, we also had to, we know it's going to go downward, so it's going to be down like a frown. So is this point here a maximum or a minimum?
Maximum.
It's a maximum, good. This was the stuff you guys were doing in 5-1. Very, very straightforward. What does every single parabola have?
Zeros.
It has a vertex. What goes through the vertex of every parabola? What's the axis of symmetry for this? X equals 3. Thank you, birthday boy. Now, in this case, you've got y already solved by itself. Do you agree? Can I just use my calculator to find symmetric twins?
Yeah.
See how easy that is?
Can you run the symmetric twins again?
Use your calculator.
You just graph it or just
Yes, sir. Use your table. Because this is already solved for y, you should never get a symmetric twin problem incorrect.
So then, is that where you just put 0 and then?
No, you just type this in exactly into y equals and look for ordered pairs. Ordered pairs that are symmetric twins.
Oh, okay.
Okay.
Wait,
I'm still making more mistakes.
Well, partially because I was trying to go. How do you send order pair?
When you
Yeah, see how it's 2 and 4, and then it's 4 and 4, and you see how they're the same value?
that would be your symmetric twins. You're looking for ones that have the same y values. Okay. When you get into the other form, this was our 0 form, our intercept form. You guys found that one to be very easy to work with as well. In this case, let's say you had 3x minus 1, x plus 5. I don't know. And I wanted to graph that, and I want to label out all my parts. Those were zeros. Your terms. That's where that came from.
Really?
You know when you guys did your not P is not Q, the converse, inverse, and contrapositive stuff?
Yeah.
Back in the day, if you are 13, then you are a teenager. If you are not 13, then you're not. Those use P and Q for the labeling of all that. That's where mind your P's and Q's came from. Is just it means watch how you're explaining something. That's all.
I thought it meant then. How does that relate to math?
You just don't start with Q.
Oh, thank you. I get it. There it is.
Wait, what? I didn't hear it.
Thank you. So my zeros then would be at 1 and -5. And we've talked about this before when we're looking at ellipses and things like in circles and whatnot. What occurs with a parabola that's halfway between zeros? What is that called? The axis of symmetry. So in this case here, all I'd have to do is take -5 and +1, and I get -4. What's half of -4? -2. So my axis of symmetry is located at x equals -2. All right. I know that this value, that a value, is positive, so it's got to be we're opening upward. 2 will be my x value for my vertex. To find my y value, it's nothing more than substitution. I take 3 times 2 minus 1, or excuse me, -2 minus 1 times -2 plus 5. So that's 3 times -3 times 3. -27? About right there. And that's how you find your vertex. Yeah. Your vertex is always going to lie on that axis of symmetry. So if you're given something that's in that intercept form, once you find your zeros, you find that axis of symmetry, you substitute in that value for x, and it gives you your y value for your vertex.
Wait, so would you multiply this by 3 and then... Wait, I'm really confused for a second. I just got really confused. I don't know why.
Well, y is -27.
Don't make a joke.
I'm sorry. All right. What I did there, are you okay with the axis of symmetry?
Yeah, I got the axis of
Okay. Once you get the axis of symmetry, your vertex lies on that. So that means your x value will be -2 for your vertex. So all I'm doing is just substituting -2 for x.
Oh, okay.
That's
I
it.
was really confused. I was writing it.
Maybe one. Vertex, maximum, minimum, axis, symmetry, so it's like that. Okay. All right. Now, I thought it was that. After we did that, then we changed our ideas for the parabolas. We changed our parabolas up to the. This is the 10-2 now. This is when we changed it to this style.
Wait, so the formulas that work from what section?
Now, after we first talked about the parabolas being up and down, maximum and minimums, then we threw the monkey wrench in and said, hey, parabolas can go left and right also. And then we showed you guys the other form of this. Obviously, we did one style of it where you were centered at the origin, and then one where we shifted. What I'm doing here is just going to walk through the shifted style because you could still use the exact same formula for the origin, just your h and k becomes 0. Yes, sir?
We don't have to find the zeros for these problems.
No, because remember, it was a real big pain to do that because you have to do a lot of simplifying. When we had them written up like this, it was more or less we would have to write out our vertex, our focus, and our directrix. Okay? We would go that way on these things.
Okay.
Yes, ma'am?
The x squared is the one that goes
Up and down.
Up and down. Yep. Because remember, you've been working with x squared parabolas all along.
Yeah.
X squared parabolas are always the ones that went up and down. The y squareds go left and right. So this is your up and down, and this is your left and right. Okay. As we go through this, what I'm going to do is just a real easy one. Let's say it's y plus 2 quantity squared equals negative 28 x minus 3. Okay. It goes sideways, yes. And why does it go sideways?
Because we got y
It's the y squared. Okay. And you can probably tell me what direction it is going to have to go. It's opening to the left, and why does it open to the left?
Negative.
Because it's negative. So right off the bat, you guys know enough information to make the idea that it's going to do that.
And it's according
Because the p is negative, right?
Correct. What's that? Yeah, because that one's negative. So I'm going to make that marking, just like we did in class with no matter what we were doing. We always rough sketched what direction it's going to go, because when I go to graph it, I don't want to make a dumb mistake. So where's your center at? Where's your vertex?
3.
Three.
Because H is on the right, guys.
I'm glad you made that mistake. What came first in the problem? It was y squared. You guys told me the vertex was at negative 2 and 3 because you didn't read it carefully. Silly people. Remember, H, K. It is very common that people do that.
You just stop.
What? It always has been.
I missed.
Y minus,
It's the same one we've been working on. It's in your calculator.
Y minus,
Yeah, just
Y minus K.
right there.
All right. Now, what'll happen is, since the y squared term came first, most people accidentally put that as their h. Don't do that. Slow your brain down. You have plenty of time to take these things. So I know that my vertex is at 3, negative 2. When I go to plot it, now I got to figure out the p-value. What do I do to figure out the p-value?
Negative 28.
Set negative 28 equal to what?
4.
Good.
Divide by 4.
So p is negative 7. And you guys have already told me that I'm opening to the left, so I have to move from that vertex left 7 spots to get my focus. Moving 7 spots over here gets me to what? Negative 4? So that means my focus is at negative 4 and negative 2. Here's my vertex. Focus. I know it's going to do this. And then I put the directrix in. With directrix, I have to go to the right now. How many spots? 7 spots. So what's 7 more than 3?
10.
And it's a vertical line, so it is x equals 10.
Boom.
Make sure you don't just say directrix at 10. No, news is at 10. Directrix is at x equals 10. I am on a roll!
Yes, you are. We're like on fire.
Now, the other thing that you also did with these is you work backwards. Okay, you also work backwards with them. You were given information and you wrote out the equation. You guys got good at that. It wasn't anything all that difficult. It was just a matter of identifying what parts were what. Okay, so let's say you had a vertex at, I don't know, negative 4 and 6, and a directrix at y equals negative 3. Okay, fine. So if your vertex is at negative 4 and 6, your directrix is at negative 3, you need to write out the equation. Well, you probably want to plot it first to figure out what direction it's going.
True.
Okay.
Truth is going up.
So if I have a vertex at -4 and 6, then my directrix is y equals -3. Y equals, is that horizontal or vertical?
Horizontal.
Horizontal. So it's horizontal through -3. Okay. So now I heard people say it. What direction is this going? It's going to go up. Everybody all right with that? So if it's up like a cup, what is is it an x squared or a y squared? X squared. Now we have to just figure out our p-value. Well, isn't our p-value the distance from here to here?
Yeah.
Just non-negative? So how far are those? 9. Are we okay with that? Yeah. So my p-value is 9. Fill in the blanks. Y, it's x squared. So it's x plus 5. Yeah.
Where did you get 5?
Why did I write 5? I was looking at the board. I wrote 4.
Why?
I am making,
He is
I was making stuff up as I go today, ladies and gentlemen.
This is from the vertex to the director.
Yes. No, it's the opposite direction. This would be negative, but since I know I'm going to be up here, my p-value is positive because it's up. So that would be 4 times 9.
Well, it would have been like absolute value.
Times y minus 6 squared.
And there's no!
Don't do it.
Don't do it! Alright? And you're done. Okay? And you're done.
I got you.
What's that? Why? Well, you were done. You should be happy. Alright?
Be happy.
Yes, sir.
We have the vertex, the one where you have to find the symmetrical twins, the standard form versus the line stuff.
No. You need to know that. I told you just get the conic ones. After that, we went to the ellipse. In the ellipse, you have the x minus h quantity squared over a squared, y minus k quantity squared over b squared equals 1. 10-4, 10-6. Ellipses were 10-4. The shifted ones were 10-6. All the shifts of everything was in 10-6. Remember the difference between where a squared is located tells you whether it's being stretched one direction or the other. If it's underneath the x squared, what direction is it going? Which one is it? It's underneath the x squared. Which one is it? Left or right? Jeez, you're not. You even have it in your calculator.
It's Monday.
So I know it's got to be that. We've already talked about why it's an ellipse versus a circle. What was the reason again?
Radius.
I don't want bugs or else.
No, what's the relationship with a squared and b squared if it's a circle? The same. They're equal. Okay. I don't speak seal. But if I did speak seal, I would sing A Kiss from a Rose. Or I'd say everybody's a little crazy.
So that's a good song.
I don't get it.
Seal, he's a singer. He was married to a supermodel.
Yeah, that's a good song.
No, somebody else. Anyway, so here's what these look like. I need a problem here.
Oh, okay. I was gonna say.
Okay. Let's make it easy. Just to walk through one real fast. Let's walk through everything. You got to remember how to set up when you're working with an ellipse.
So I think that the first one is 0. Or 1.
Which one would it be?
Let's go up and down. Sorry,
It's got to be 1. If it's 0, you can't divide by 0, can you? So, ladies and gentlemen, come on. When I'm sitting through on this one, there's no batteries in it.
Just hit the fish. Just hit it. Hit the fish.
Will you ever?
In this case here, obviously, that's over 1. Okay? So what direction is this one being stretched?
Up and down.
Vertically, very good. It's going up and down. Now, please, ladies and gentlemen, once you know that, do that so you don't do a dumb thing on the test.
Jelly bean.
You know how many times people do that? Isn't a jelly bean on the side still a jelly bean?
Yeah.
Okay. So don't screw that up.
I'll give
It's a corn cob. I'll get used to it.
Where's your center? I didn't even miss a step. I was all over it. One negative.
Oh, wait, K minus. Oh, that's X. Shut up.
What's a squared? A squared is always the bigger of the two. Last time I checked, 16 is bigger than 1.
Well, you must probably check
So C squared is 15. All right. So remember, when you're trying to find your C squared value here, it's just A squared minus B squared. So that gives you your A value of plus or minus 4, B value plus or minus 1, the C value of plus or minus root 15. Now, if I can't simplify the square root of 15, can I? If it was the square root of 12, what would I write? 2 root 3. If it was the square root of 18, what would I write? 3 root 2.
Plus or minus 3 root 2.
What is the square root of 48?
Yes.
Root 6.
So.
Square root of 3. All right. So when we start this then, I was just checking. When I start this, plot the center, 1, -3. I know this is stretched vertically, so when I go to walk to my vertex, I walk up 4 and I walk down 4. If I walk up 4, I am at 1, 1, walk down 4. I'm at 1 and -7. So I have vertices at 1, 1, and 1, -7. See how I'm listing everything, just like we did before?
Yes.
Co-vertices are your B value. So the co-vertice, I'm moving to the right one and the left one. So now I'm at 2, -3, and 0, -3. Foci. My foci are at plus or minus the square root of 15. Last time I checked, the square root of 15 is almost the square root of 16. So it's less than 4,
3.8.
but more than 3. So it's 4-ish or 3-ish.
Yeah.
Oh, here.
3.8 times.
Over here.
Can we make a new rule?
How do I write that?
1,
Go on, go on.
3 plus 3.
And then the other would be at? And there's your foci. That's how you label it out, just like we did in class. Okay? And you're done. You're able to list out, put all your parts together, and get the ordered pairs. Those are exact solutions. It's not scary, is it? Yes. The way that you define the ellipse is that every point on the ellipse is always, if you added it to the, if this is from wherever that point is to the focus is, foci, it stays constant. So if I was here, the distance from here to here is the same if I was here, going from here to here. It stays constant. Okay?
So will the questions in the test be like a lot of the stuff that we're seeing?
Exactly. I'm not, why would I change it? Why would I change it? There's no reason. Why would I assess you on something I haven't compared to?
So we are getting
Everybody except for you. Yes, ma'am. What's that? Oh, sorry. What do you got? Notice how you have your vertices are vertical. Your foci will be vertical as well. Your vertice always opens to the foci. Always. So that means your foci and your vertex and your center will always be on that same symmetry line. Same thing if it was twisted this way. They'd all be on the same horizontal line. When they're vertical, they will all have the same x coordinate.
So we get like -3 from the y. I know.
Oh, I should have done that. Did I just add that to the wrong value?
I think so. That
Oh, no, because we're adding it to the y, just moving it up. We just moved it up. So at 1, -3, if I raise it up, I'm adding it to that to raise it up. Okay, it's on the same vertical, that's why the 1 is the same, it's the y's that change.
Okay, I forgot that was 1 -3.
Yes, ma'am?
You only find both sides are elliptic,
The parabolas have them too.
but not circles?
No, because the circle, if it was a squared minus b squared, it wouldn't exist. Because the a's and b's are the same.
You can just pull that and calculate it because
You still have to do all your order. Yes, sir.
Do we have to classify the conic?
This is what you're doing. When you go to classify the conics, this means you set up to complete your square stuff. The other thing you guys did with the ellipse here, come on guys, I got a couple more I want to get done with you. When you're working through with the ellipse stuff, you had to write equations given certain parameters. So if you had stuff like this, if you're given the fact that this is an ellipse, if you're given an ellipse with specific vertices and in this case foci, you're able to distinguish what the A's terms are, the B's and the C's from just that information. Albeit it takes a minute or two to do, but it's not correct.
Anything's possible.
All right.
You said it's not correct, like, because
it's not.
correct.
I wasn't listening.
Someone said something like it's not. Correct.
Oh,
Yeah.
We only
Yeah.
know you're dead, but it's not.
I guess you had to be there. You're right. I must not have been there. Anyway, first thing I would do with something like this is decide what direction it's going. Okay? So I'm going to plot it. 9, -9.
Let the man do his plot.
And then -3 and -9. So which direction is this going?
Horizontal.
These are horizontal. Those are my vertices. I know that those are my vertices. My vertices are horizontal from one another. That means it's got to be moving horizontal. Okay? So is this an x squared or a y squared ellipse? It's an x squared. Here's what I'm going to do. I know it's got to do this. I'm going to write x squared over a squared just so I don't forget. I know it's not the full generic form, but it's just getting me started. If those are my vertices, what occurs at the midpoint of the vertices?
Center.
The center. So what's -3 plus 9?
6.
What's half of it?
3.
So your center is at 3. Your HK is at 3, -9. We okay with that?
Yeah.
All right. Well, we're not finding C yet. We're going to find A first.
I was saying C as in
I know.
I'm making a joke.
Hey, it looks like a smiley face.
No.
In this case here, the A value is the distance from your center to a vertex. How far apart are they? 6. So A is 6. What's A squared?
36.
Okay. Now, take a look at what they gave you for your foci. 3 plus root 11. 3 minus root 11. What's your C value? Root 11, bless you. Your C value is the square root of 11. What's, bless you? What's C squared?
11.
Okay, so what's B squared? It's 25. Remember, C squared equals A squared minus B squared. 11 equals 36 minus what? You get 25. So you're done. You've got x minus 3 quantity squared over 36 plus y plus 9 quantity squared over 25 equals 1.
Where'd you get the B?
The b value comes from c squared is a squared minus b squared. I have 11 equals 36 minus something. We just did it verbally. Okay? Once again, a lot of these things, if you got good at it, you might not even need to graph it, really, to be honest with you. Okay? And then the last type of thing is that what Ali was talking about with the classifying of conics. When we're talking about classifying of conics, you don't need to use that discriminant stuff that's in your book. Because more often than not, I'm just going to ask you to graph it. I'll give you the wrote out version of the quadratic form. You have to do all your completing of the square to get down to the nitty gritty of is it a circle, is it a parabola, or is it an ellipse. It is so blatantly obvious that it won't be a parabola sometimes because there's only a parabola only has one square term, whereas the ellipse and the circle have 2. So let me walk you through one of those real quick.
Yeah, let's go through every question on the test, Mr. Murphy.
Put that up on the documents and then it's all standard.
Square, that's 36.
Ooh, I know this one.
That's an ellipse.
Wait, is that one of
Yeah, because we've been working on this stuff for a while. Oh, this? No, this is just me making problems. I just wanted to make sure it worked before I.
So you just do math?
I don't know.
I hope not.
This is the same stuff. We did this style problem for parabolas. We did it for ellipses, and we did them for circles. They call it classifying the conic, but what we did is we just went right ahead and completed the square. Because once you complete the square, it forces you into that generic standard form of the x minus h quantity squared and all that. So when you complete the square, the first thing you want to do is get your x terms together, your y terms together, and move the constant to the other side. Let's do that. So it's x squared minus 16x plus 36y squared minus 72y equals negative 64. Everybody okay with that? Yes. Obviously with the x squared terms, I don't have to worry about too much hassle here, but I have to worry about the y squared terms. What do I have to do to the y squared? Very good. I'm going to factor out the 36. So I'm going to write this as x squared. Let me move this down. This is going to be negative 16 divided by 2 is negative 8 squared. I get 64. Everybody okay with that?
Yeah.
All right. Let me kind of shortcut this. We're running out of a little time here. So I know that this term is going to be x minus 8 quantity squared. You okay with that?
Yeah.
All right. On the other one here, I got to factor out the 36 to start with. I factored out a 36, I have to remember to multiply that term by 36. Okay? The other one I didn't have to worry about anything because it was just there was no leading term coefficient. We took half of negative 16, got negative 8, we squared it, it's 64. We add that to both sides. There's that 64. That gave me a perfect square term of x minus 8 quantity squared. Okay? This would be a 36. What's half of negative 2? So we have negative 1. I square it, and I get plus 1. So I'm going to add a plus 1 right there. So my term here becomes 36 times the quantity y minus 1 squared equals 36. It's going to be an ellipse. Everybody see it's going to wind up being an ellipse?
Yeah.
So once I divide out by that 36 now, you see why I'm going to divide this now by 36, whereas the other one I didn't have to because there's a term here. Okay. So when you divide out by your 36, you get this becomes over 1, then this is 1, and yes, it's obvious that this is an ellipse. In which direction is it shifted? Horizontally, and you could graph it from there. Yes, sir?
Will we have to
Oh, yeah.
test at one point?
Yeah. What I did with the graph stuff is that I made sure that most values would be somewhat
easy to plot, so I put grids on the paper for you. So you've got a little bit of the graph. Because I know as we were building into a lot of this stuff, you guys were kind of going through the motions of making the graphs, which is fine. I've been looking at your stuff. You guys are doing really well at it, but I didn't want you to have to stumble and freak out that you couldn't count a tick mark if you did something wrong, okay? So I want to make sure you had that. For the most part, I don't think it's really all that tough, to be honest with you. I say that all the time because I write them. Yeah, I know. You can write them, that's sure. You can write them all you want, but not going to use them. Very well. Questions? More problems you did in class. Yeah. All right. If I were you, I'd go through some chapter review problems, look at some completing the square stuff in 10.6. Remember, some of the 10.6 stuff you have not done yet. There is hyperbola still in 10.6, so if you wind up with something that you don't know what you're doing, it's okay. You did them already?
No,
Oh.
they won't be on the consent.
I could.